Hello. Oh, and welcome back. So glad to see you. Okay, so in the last few videos, we were just kind of going over how to read in data and how to organize your files, hopefully, so you're nice and organized and not losing things. And we were doing all of that, kind of getting a feel for RStudio. Okay, now what we're doing, some more fun stuff, I think. We're going to be summarizing data and manipulating data. Okay, now both of these things are pretty important, obviously. You'll probably recall if you've taken Stat 2050 recently, summarizing data honestly is super tedious if you do it by hand. Okay, and that just looks like you're given a bunch of numbers. You have to calculate the mean and the standard deviation and the first quartile and the median and blah 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 blah. It's such a pain. Oh my gosh, I'm so sorry that you had to do that. Honestly, I really am. Um, Thankfully, though, we have R now, which is in this case going to be a real fancy calculator. It's really great. So, with that being said, you could say goodbye to the days of tedium and pens and paper. Okay, so let's get into it. So we're talking about data manipulation first. This actually, data manipulating and sort of the concepts that go along with that, it's a job in itself. You can hire people, data engineers, to format data in ways that are easier to work with, and that's what we're going to be doing here too. Not so much at the same extent as you would find in the industry, but at least kind of getting our foot in the door there. And that just looks like subsetting data, so you're only containing certain observations, removing certain observations, adding, observations, rows, all this kind of stuff, right? And it's a whole thing. It's a whole thing. So we actually have a few ways of doing it. We have base R functions, which is what we've been using the whole time. That's the stuff that just comes preloaded into R. Totally functional, works totally fine. Sometimes they can be a little finicky. Sometimes they aren't. Sometimes they're nice and simple. But we also have what's called the tidyverse, and that's an extension of R and RStudio. And let me tell you right now, oh my gosh, it makes life so much easier. I cry tears of joy every single time the tidyverse makes my job easier. And we're going to be using the tidyverse a ton in this class. It's kind of the future with the way that most R packages are being written now. It's also very similar to how Python operates, if you're familiar with that. As far as kind of the flow and the efficiency of it, it's really great. It's really great. Of course, there's always more than one way to do something in R, as as is in real life. Again, it's your choice. I think the tidyverse is easier. It does require an extension. Requires you download something, but it's very easy to do, I promise. So let's get into it, because I've got an example here. Because we're making, oh, so we're making money. Okay, we're making a ton. Okay, so the thing that's happening here is we've got a scientist who's working on how age and sex affects muscle density. Okay, and they come up to us and say, hey, I'm only a scientist. I'm only a physiologist. Um, Not to be disparaging, of course, but this is what they do, and they're very good at it. But we're statisticians, right? And that's our job. And they come up to us and say, hey, I actually have a data set, and I only want it to contain the males that were in the study. For some reason, they just want to separate males and females for their analysis, and that's totally fine. They don't know how to do it, though. So they pay us 10K, man, 10K, if we can organize their data for them, which is great, which is great. So let me actually go back one. This is what's called subsetting data, which is exactly what's happening here. Subsetting or analyzing a certain subset of the data. Okay, and we are given this muscle density problem. So instead of me just kind of flying through it here, blah blah blah, we've already got it read in, which is great, in R. Okay, so this is from the last example. Hopefully you have it read in. If you haven't, just come up here to session, wherever your data is stored, choose that working directory and get it going. Okay, so I've got a couple of tasks here. I'm going to take it one at a time. I'm not going to make a 4-hour long video or whatever. We're going to do one task at a time. Okay, so the first thing we want to do is let's actually just take a look, because it's in a book. Reading Rainbow, man. Sorry, that's just my childhood coming out. So we want to take a look at the data, and let me actually rerun this just to make sure it's all in there. And let's take a look. Okay, very, very cool. So we've got 60 observations of 3 columns, 3 variables, 3 columns, named age, density, and sex. Okay, so there's a few things here that I want to change. The first thing is this column name, age, looks kind of weird. Okay, it looks like that for me. It may not look like that for you. And if it does or doesn't, whatever, that's totally fine. I'm going to show you how to rename columns in an easy way, just to make your life much easier. And there's also another thing here too. Age has got 3 letters. Sex has got 3 letters. Density has got 7. I don't want that. I just want this. I want everything here to have 3 letters. I'm going to abbreviate this just to make my life just a little easier. Okay. So we've got all of that where we took a look. It's kind of fun to say. So check. Now we want to summarize data. We also need to fix the data just a little bit. Let me actually let me put that there too. Fix, summarize, and then show the structure. And I'll get to that in just a second. Okay. So what I'm going to do, here's the first little bit of code. I'm going to use this function called names. And all that's going to do is say, let's take a look at the names of muscle. And if I were to run this, check it out. It spits out the column names for each column in our data set. Okay, in this case, we only have 3. If there were more, it would be a lot more. And I actually just want to rename each one of these, except for this one, but whatever. So what I'm going to do here is I'm going to say, well, the names there, it's going to get, and then I just want to feed it new names. Let me move that. I just want to feed it new names. Okay. And so if I were to go like this, if I said, okay, I actually want to rename age, that age, I want to rename that to just age. I want to rename density to maybe den, just to make it short for me. And then sex, we want to keep it the same. What do you think is going to happen here? We're going to have an error. It's going to be an issue. Age, object age not found. That's kind of weird, right? Because, well, I don't have anything saved over here as age. That's what that's saying. The age is not found. What I need to do if I'm renaming columns, I need to put these in quotation marks. Easy enough. Easy enough. Check it out. Okay, so I ran that, no error. Comes down here, and then we'll take a look. Oh my gosh, so much easier. So much easier. Okay. Now, what I want to do, so we fixed that. So we took a look, we fixed. I'm going to show the structure of the data next. We'll summarize it here in just a second. But let me actually go back. Let me go back to the old PowerPoint and show you, nope, how to get the structure, okay? So this is what it should look like. This is what it should look like. We should have 3 things once we run this line of code. Let me go back to R and do just that. So I'm using this str, stands for structure. I'm putting muscle in that, my data set called muscle. I run that, cool. Okay, so if you come down here, take a look in the console, this is the output. We see that age is an integer, int stands for integer, and I've got a nice little slide on the PowerPoint with all of the translations for these things. But age is an integer, density is an integer, that just means they're whole numbers. And then sex is a CHR, a character. That's actually an issue. That's an issue because I don't want it to be a character. I want it to be a factor. I want it to match. I want it to match this. I wanted the computer to realize that there's 2 things in here, F and M, okay? Not necessarily these just letters. How am I going to fix that? We're still fixing here, okay? And this is all, this might not be an issue for you. It is for me, but this is good. This is good because it's going to show us a few things, okay? So I only want to work with the column called sex. That's the only thing I want to work with. Well, in R, if I were to just type this in, type in muscle, what's it going to do? It's going to spit out the whole data set in the console here. Well, it turns out that in R, we could use this $ here. Whoa. And then it automatically pulls up a little list here of all the columns in there, age, density, and sex. And I only want to work with this. Okay, so if I were to just run this, so Control Enter, look at that. I get, here is the first kind of row here of a bunch of Fs, and then the 21st, this is the 21st observation here. And then the 41st observation, we kind of see that here by the index, quote unquote, blah, 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 right? And it goes all the way up to 60, okay? I don't want that to be a character though. I want it to be a factor. And factors, we're gonna get into this in just a little bit. But to fix that, all I wanna do is give it this function as.factor. That means turn whatever is gonna go in here into a factor, into something with some differentiation in it, okay? So we'll copy and paste this because we only want to work with this column, okay? And we just want to turn it into a column. Now, you're probably wondering, well, like, why can't I just run this line? Well, let me show you why. If we don't store it as anything, it's just going to spit it out. It's not going to actually do anything. It's just going to print it, right? So we just bring back that. Booyah. Look at that. And now we are set. And if I were to come back here and run structure on our data set, booyah. Look at that. It should match identically to this. And it does, which is great, which is super great. Okay, so we took a look. We fixed. And we showed the structure of the data. We've got 2 columns of integers, whole numbers, rounded numbers, and then a column of a factor with 2 levels, males and females, okay? And then the computer spits out ones or zeros or whatever. We're not going to worry about that for now. That's just the computer doing its thing, making sure that it's treating things properly, okay? Now, STR stands for structure. And let me actually move this too. Okay, so STR stands for structure. Now all we need to do is summarize the data. Well, we want to get a summary of the data. I wonder what that function looks like. You guessed it. It's just summary. It's great. It's so easy. And so all we want to do is then just put our data in there. Okay, and then it's as easy as that. We have the summary function. Too many M's, my bad. Summary function, we run that, look at that. Let me actually, ignore that for a second. I'm gonna show you what happens when we have a mistyped function. Error in summary, could not find function summary with 3 M's, right? R is pretty smart in saying like, I don't know what the heck this is, do something about it. Okay, so let me just remove that M, booyah, okay. Let me kind of move this down so we're not confused here. Cool. Okay. Now what the heck, what does this look like? This should be very similar to what you saw in intro stats. And that's that 5-number summary with the mean also in there. Okay. So we have the minimum, the first quartile. Let me actually write all this out too. So the min, a little translation here. That's the minimum minimum value. Okay, so the smallest value. So in this case, we're working with age here. This is years. Okay, this is people's age. Okay, so the youngest person in this study was 41 years old. Okay, the first first quartile is the 25th percentile. Okay, that means that 25% of the people in these data, the lower 25%, are 50.25 years old. Okay, so 25% of the data is below that number. Okay, with these data. The median, similar story, except it's the 50th percentile. Easy enough. That's the halfway point. 50% of the data are below 60 years old, and 50% are above 60 years old. Then we get the mean. That's just, we're just going to call that the kind of traditional average for now, right? The expected value. the expected value. Okay. Oops. Cool, 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 cool. No doubt, no doubt. All right. Next thing, moving on. Third quartile, you guessed it. It's the 75th percentile. Easy enough. So that's the 75th percentile. That marks where 75% of the data are. And then we've got the max. And yes, you guessed it. That is the maximum value. Very cool. Very cool. How long did that take? Aside from me talking about it, a single line does all of the math for us for each column, right? So we have here for the integers, we've got a 5-number summary plus the mean. We have density. I don't remember the units for this. Again, doesn't so much matter. We're just kind of learning how to code here. We get the same stuff, right? So the minimum value for the density is 52 density units. The maximum is 119 density units, so on and so forth, right? And then we have counts for the sex. So there's 33 females and 27 males. Look at that. Do you know how long that took? We just made $5,000 because the next thing we need to do is subset the data. And let me just double check. I'll leave this kind of up here. Let me take a look on my other monitor here. I think, let me just show you. This is not super, super important, but going back to the kind of data structure, we're going to be working mostly with kind of this area here, mostly with data frames, not so much everything else. Definitely not arrays, at least in this class. But let me kind of show you what's going on here, right? So homogeneous means that just everything is the same in it. So one-dimensional, so it's just one column. Is just a vector. And if it's all the same stuff, it's all numbers, you get a vector. If it's heterogeneous, then that means that there's numbers and characters in there, or factors, whatever. Then you get a list, okay? And then if you have more than one column and it's all numbers, then it's a matrix. And if you have more than one column and it's a mix of numbers and characters or factors or whatever, you get a data frame. And that's actually what we're working with right here. You get a data frame because we have one column of numbers, another column of numbers, and then a column of characters or of factors. Okay, and then we kind of see that here. If I were to rerun the structure, it gives me, as a data frame, a little bit of the information, and then the overall kind of characteristic of the columns inside. And we can kind of, sorry, one last thing. And we can kind of see that here too. Very cool. Very cool. Again, this is not totally, if you get lost in this, no worries. This is just background information that is important to know, but I won't, test you on it or anything. Okay, with that, I'm going to pause it and I will catch you in the next one.